You know, you see it every single day. The sun crawls across the sky. But have you ever really stopped to think about what's actually going on up there? It seems so simple, but the real explanation, well, it gives you a totally new perspective on everything. So let's get into it.
So here's the fundamental question, the big one. Does the sun move across the sky, or do we? I mean, it seems so obvious, doesn't it? The sun rises over there, sets over there. It's clearly the one moving. But what if? What if what your eyes are telling you is a kind of grand illusion? That's the puzzle we're going to solve together today. And our journey to the answer actually starts somewhere pretty down to earth, not in some high-tech observatory, but with a simple, everyday observation from a student named Rashmika. She just noticed something about shadows, and it led to this amazing question.
So Rashmika's looking around and she sees that in the morning, the shadows are super long, but then by the afternoon, they've gotten way shorter. And logically, that has to mean the sun's position is changing. But then she thinks, wait a minute, in school, they taught us the Earth moves around the sun. So which one is it? Is the sun moving or are we? It feels like a total contradiction, right? And that's exactly what we're going to unravel. Okay, to wrap our heads around a puzzle this huge, I mean, it's literally planet size, we need to bring it down to a more human scale. And the perfect way to do that is with something most of us have probably been on, a merry-go-round. So just imagine you're on a merry-go-round. You're holding on and it starts to spin. What happens to everything outside the ride? The trees, the benches, your friends just standing there watching? Suddenly, it looks like they're the ones spinning around you, even though you know for a fact they're standing completely still. And that right there, that's the absolute key. Your motion creates the illusion that the stationary world is moving. And here's the important part. It always looks like it's moving in the opposite direction of how you're spinning. This is where it all clicks into place. Let's say the merry-go-round is spinning anti-clockwise. To you, on the ride, it looks like the trees and the whole park are just gliding past you in a clockwise direction. See that? It's a perfect mirror image relationship.
Okay, get ready for it because here's the big aha moment. What if we just take that same exact idea and scale it way, way up? What if Earth itself is our giant merry-go-round spinning super slowly and the sun, well, the sun is just like that stationary tree we're spinning past every single day.
And that one powerful idea brings us straight to the scientific concept that explains it all. The sunrise, the sunset, the entire day. It's called Earth's rotation. So what is rotation? It's really just the official term for an object spinning on its own central line, what we call an axis. You've seen it a million times. A spinning top, a basketball bounced on a fingertip. Well, our planet is doing that exact same thing, just on a scale that's almost impossible to imagine. Now, this axis isn't a physical pole you can touch. It's an imaginary line that runs right through the center of the Earth, from the North Pole all the way down to the South Pole. And our whole world is just constantly, endlessly spinning around this invisible line. The direction it spins in is super important too. The Earth spins from west to east. So if you could just float in space and look down on the North Pole, you'd see it spinning anti-clockwise. And hey, remember our merry-go-round? What happened when it spun anti-clockwise? The world outside looked like it was moving clockwise. It's the same exact principle. So how long for one full turn? You already know this one, of course. It takes 24 hours. That one single, steady motion is basically the heartbeat of our entire planet, the rhythm of our day. All right, so we've got this 24-hour spin. How does that create the thing we see every single day, the sun's journey from one side of the sky to the other? You know, the answer is so elegant. It's beautiful. As the Earth is spinning, one half of the planet is always facing the sun. That side is lit up, so it's daytime. And the other half? Well, it's facing away, looking out into the dark of space. For everyone over there, it's nighttime. Simple as that. Let's put you on that spinning globe for a second. In the morning, your part of the world is rotating into the sun's light. From your perspective, it looks like the sun is rising in the east. Then by midday, you're rotated to face the sun almost directly. It looks like it's high overhead. And as the day goes on, you keep spinning, rotating away from the light. And it looks like the sun is setting in the west. But the whole time, the sun wasn't moving. You were. And you know what's wild? This idea isn't new. This isn't something we just figured out with space telescopes. For thousands of years, brilliant minds have been looking up and figuring out this cosmic dance just by carefully observing the world around them. I mean, check this out. Over 1,500 years ago, an Indian astronomer named Aryabhata totally nailed it. He used a different analogy, a boat. He said, hey, when you're on a boat moving forward, the trees on the shore look like they're moving backward. He realized that's exactly what's happening to us. We're on a spinning Earth, and the stars, which are stationary, just seem to be moving past us.
And if that's not mind-blowing enough, get this. His calculation for how long one rotation takes was 23 hours, 56 minutes, and 4.1 seconds. That is unbelievably close to what we know today. We're talking about a guy in the 5th century. It's just, wow.
So, okay, we've cracked the code on the daily puzzle. We know why the sun seems to move. But that daily spin, that rotation, it's only part of the story. It turns out the Earth is doing another dance at the exact same time, a much, much longer one. And here's the last big piece of the puzzle for today. We have rotation, that's the 24-hour spin on our axis that causes day and night. And then we have revolution. That's our 365-day trip around the sun, our orbit, and that's what causes our entire year. So you've got this daily spin and this yearly journey, two totally different dances happening all at once. So our daily spin gives us the sunrise, and our yearly trip gives us, well, our entire year. It kind of makes you wonder, doesn't it? What other huge cosmic movements are we part of right now that we can't even feel? Our whole solar system is moving. Our galaxy is spinning. What other grand illusions are out there just waiting for us to figure them out?